During this program, we are going to see beautiful pictures of the largest planet in our solar system, Jupiter. We will also see some of its 14 known moons in surprising detail. These pictures are better than the Pioneer spacecraft pictures of Jupiter we saw during the previous program. I'm Larry Ross, Director of Space Programs at NASA's Lewis Research Center in Cleveland, Ohio, and I'm your host for this 10th program in our series of 13 called Journey Through the Solar System. Now, let's see a videotape made after the Voyager 1 spacecraft had its closest encounter with Jupiter in 1979. Rodney Mills of NASA describes the Voyager pictures.
This is an image of Jupiter we obtained from a distance of something like 50 million miles, but we were immediately struck by the fact that it looked somewhat different than it did when an earlier spacecraft, the Pioneer, flew by in about 1973 and 1974.
In what respect? The bands? Or?
The bands and the zones look different. The appearance of the great red spot looked different, and a number of other features.
So it's very dynamic.
It's a very dynamic place, yes.
Is it solid?
Jupiter may have a small solid core about the size of the Earth, but for the most part, it's a large bag of liquid and gas, mostly hydrogen. Now, we don't ever see the solid surface. All we see are the cloud decks. We don't know what gives them the color. We have some suspicions, and maybe some of our data will reveal that.
In the years ahead, we have a mission that will take a satellite to Jupiter and penetrate these gases, do we not?
That's right. We have a mission on the books right now which will include a probe that will go down and penetrate into the surface and actually into the surface of the clouds and actually take some measurements.
That'll be exciting. What are some of the others that you have?
Well, I think this is one of the more beautiful of the photographs showing two of the satellites passing in front of the planet. Now, Jupiter has about 13 satellites or moons. Of these, 4 of them are very large. They're the ones which Galileo discovered. And in this photograph, you can see 2 of those moons passing in front of, between the spacecraft and Jupiter.
How about the sizes?
The satellites
are they like
are large.
Like?
They're large. Actually, 2 of them are larger than the planet Mercury. The 4 Galilean satellites are Io, the one closest to the planet, then comes Europa, then Ganymede, then Callisto. 2 of those are larger than Mercury. 3 of them are larger than our own moon. So they're all really planets in their own rights. What we have out there, Jupiter, is really a miniature solar system. We have a large body which is radiating more heat than it receives.
Possibly another sun.
It's a sun that didn't quite make it. Right. But and the density of these satellites varies considerably, just like the densities of our own planets vary. Yes, the ones closest to the central body are hard rocky objects, and the ones further away are less dense. This is a close-up view of shows the great red spot. This is a feature that anyone who has a small telescope can possibly identify on Jupiter. Galileo observed the great red spot. So we know it's been in existence something like 300 years. Now, it moves around the planet a little bit, but it never loses its identity completely. And this is amazing, considering it's really just a storm and a cloud formation.
That's large, too, as I recall, about the size of 3 diameters of the Earth.
It's as wide as 3 diameters of Earth, so it's a large storm. Now, we were very interested in where the energy comes to make this thing exist, and we were interested whether it was rotating or not, and we have found that out. We have found, for instance, that it rotates once every 6 days. I should mention also that Jupiter has a lot of energy. it spins on its axis so that a day on Jupiter is only 10 hours long.
Aesthetically, the photographs are beautiful.
Let me show you some examples of the beautiful arty photography that's come out of the mission so far. This is a view of a portion of the planet Jupiter in its normal color. Now, as an aid to trace the flow of the atmosphere, we introduced some artificial coloring, and it comes out very remarkable. This is an example.
We're then going to learn a lot about the dynamics of motion and the flow patterns.
In fact, we photographed the planet Jupiter continuously over a period of a month with still photos, and now we've assembled them into a movie which we can run and speed up the motion, and you can actually see the flow of the atmosphere and the appearance and disappearance of clouds. And our scientists are busily engaged in analyzing that.
It certainly looks different than anything we've seen at any of the other planets. What else do you have here?
Well, before I leave it, let me show you a spread out map of the entire planet Jupiter. This is a new result that's just released this week. This is the equivalent of a Mercator projection. It shows all sides of Jupiter at one time, and it's unusual in that most of us didn't realize how many various plumes and spots there are on the planet, and all of these things move in the movie that I spoke about.
Do they all go at different speeds relative?
Yes, they go, in fact, tend to go in opposite directions. Some of the bands flow one direction, like eastward, and some flow westward.
Lots of questions.
Yes, lots of questions.
And some of the dark spots we had seen and some of the white spots we had seen prior to the...
Some of the white spots down in the southern latitudes have been observed for around 30 or 40 years. I mentioned that the Great Red Spot has been observed for 300 years. Some of the features appear in a matter of a few days or a few weeks, and then they disappear. Yeah. To go on, there were several other features that I should mention about Jupiter. We made a remarkable discovery, and we found that there is a ring around Jupiter.
I understand that.
Right. Now we know that, of course, Saturn has these beautiful silvery rings, and a short period of time ago we found that Uranus has some thin rings, and now Jupiter has joined the club, so it leaves Earth out almost. This illustrates where the camera was aimed. We took a single exposure out in this area where the little square is located at the time we crossed the equatorial plane of Jupiter with a spacecraft, and we took a single 10-minute exposure, and I'll show you the resultant photograph. This is a black and white photograph, and it takes a little explanation. These strange wiggly marks up here are actually images of stars, because the spacecraft was moving during the 10 minutes, so the stars actually left little jagged traces. But in the central portion of the photograph, you'll see these straight lines. Actually, there's 6 separate images. That's right, yeah. And that's the edge of the ring looking straight on at it. Yeah. Now the ring is very dark. It's fairly thin, probably not thicker than the 20 miles or something like that. It's composed, we think, of rocks, and they're very dark. But we'll be taking more images of this with Voyager 2.
Yes, now that you know it's there.
Now that we know it's there, right.
More directly.
Right. And since we discovered it, I believe there has been an observatory here on Earth that has also confirmed the discovery. This photograph of Jupiter has had a ring drawn on it by an artist to give you some idea of the size of the ring. Well, although we know approximately its thickness, we really don't know the extent of it inwards towards the planet. And we will be measuring that with the next spacecraft.
Are these rings always in the equatorial plane of the planet?
Yes, right. That's, in fact, that's a requirement almost.
Possibly something that never was quite formed into what it should have been into another satellite? Or
it could be the broken up debris of a small satellite, and that's probably likely. There is another object that's fairly close to the planet Jupiter. This is the small satellite Amalthea. It's really not one of the Galilean satellites, but it's the innermost satellite. And this had never been seen by mankind before as anything other than a point of light. In fact, very few astronomers had ever seen it. It's really a small rocky object. It's not spherical in shape. Its approximate size is like 80 by 150 miles. It's very dark, very red. It may be just a captured asteroid.
Traveling pretty rapidly, probably, too, because
Right.
it's close to the planet.
As the spacecraft swung behind the planet Jupiter, we took occasion to take some images of the dark side of the planet, and we made another remarkable discovery. This is a photograph. It appears rather noisy, but in fact it contains quite a bit of information. This light arc across the top here is actually an aurora display, like the northern lights here on Earth. Right. The atmosphere is being excited by charged particles spiraling in. Then down lower in the photograph there are some bright white spots, and we believe that's evidence of lightning. Lightning above the cloud tops.
Is that right?
The same sort of thing is seen sometimes here on Earth down in the tropical areas, and they're called superbolts. It's a great deal of energy. And these measurements were later confirmed by our spacecraft. We have on the spacecraft an instrument to listen to the planet, and we heard electrical waves corresponding to whistlers, which are created by lightning.
What about some of the other satellites?
Let me speak about the satellites, not exactly in the order we observed them, but the outermost of the four large satellites is Callisto. Now, Callisto is not very dense. We know that it has a density that not about halfway between water and rock, so we know that it must be composed about half of ice. It's rather a cold object. It has no atmosphere. This is a color photograph we obtained of Callisto as we flew by it, and we were immediately struck by the fact it's heavily cratered, probably more heavily than the moon is even. And this is evidence that it's not changed much in the last 4 to 6 billion years.
No atmosphere.
No atmosphere. There's apparently no volcanic action, and it's stayed frozen.
It has rings, or appears this.
Right. There is one large impact basin up there where it looks like some very large object had struck it and formed concentric rings around the basin, and those have been apparently frozen in the ice. So it's and elsewhere you can see some small craters that are very light appearing. It looks like the dark covering on the planet has been thrown aside, and it's exposing probably ice.
Newer ones, possibly, newer craters?
Well, we think probably it was cratered at about the same time in history that the Earth and the Moon and Mercury were, and that was back in way before our time, probably 4 to 6 billion years ago. But it hasn't changed much since then. This is another photograph in color of the entire planet, Callisto. Actually, it's a satellite, but it really deserves to be considered as a planet. And finally, a third photograph of Callisto, which shows in black and white a little more of the cratering detail. You can see
it has been impacted.
it's pockmarked a wide range of sizes. Also, if you notice along the limb or the outer edge of the satellite here, you'll notice there isn't much relief. Apparently, there are no mountains, and that's consistent with the theory that there's a lot of ice in the satellite, and it really couldn't support mountains. Next, moving inward, I'll talk a little about Ganymede, which is probably one of our favorite satellites because it has such a diversity of appearance. Again, here's a full image of Ganymede. You can see it's a different color and has a different texture. There are light areas and there are dark areas. We think the dark areas are a little bit older and the light areas are a little newer. There's some evidence here that the surface has been under a lot of stress and it has been altered during the eons of time since it was formed. There are a fair number of craters, but not as many as on Callisto.
This would be dense, now more dense than what we had seen before.
Right.
More rock, possibly.
A little more rock, but still an appreciable amount of ice and water, of course, if it were warm enough, but it isn't.
Right.
This black and white photograph illustrates the rough texture we see on portions of Ganymede. This looks a little bit like some dune buggies have been running around in the sand. Actually, the scale is quite a bit larger, and either the surface has been compressed or stretched and given rise to all these ridges.
And we have impacts as we see there.
Yes, so you can see that whenever that happened, it was still before the end of the cratering action took place. Our geologists are having lots of fun with these images. One more rather remarkable photograph here of an area showing both the light and dark surfaces. And we have an example here of a fault line. It's the only place besides the Earth we've seen any evidence of earthquake fault lines. I'll try to point it out down here. You'll see a displacement down in this region of the lighter area where
it's been moved from
it's been
off
moved
to the left, the whole
right.
So fault lines from there. We've not seen this any other place?
No, not on the Moon nor Mercury, and of course, not on Mars. Of course, we haven't seen the actual solid surface of Venus, but so far, this is the only other place in the solar system. Now, moving into the next satellite. This is an image of Europa. Now, this is a rocky satellite. This is actually the best photograph we obtained with Voyager 1. It didn't come very close to Europa. We'll do much better with Voyager 2. Our pictures will be about 10 times larger with Voyager 2. But there's a very interesting feature here on this satellite. You see these long, straight lines down in the southern hemisphere? We don't know what they are. They could be just surface markings, or they could actually be crevices, long, huge canyons. If they are, they're much greater than our own Grand Canyon. They stretch thousands of kilometers.
What's the size of the planet itself?
This again is it's smaller than the Earth, but it's comparable to the Moon.
To the Moon. So we're looking at cracks there, or whatever they are, lines that are a quarter of the distance on the surface, or more even in some cases.
So we're looking forward to the next trip by this satellite.
Io is a pretty interesting satellite.
We have some people with remarkable imaginations, but none of them had imaginations good enough to expect what we found on Io. It's a very remarkable object in the solar system. This is a color photograph showing it has a very goldish, reddish color with some white areas. Now, we expected Io to be a little different, and we expected it to have some salt flats on it, and I think it does. But one of the first things we noticed is there seems to be no evidence of cratering. These other bodies have all shown craters from impacts, and so why shouldn't Io? Well, we thought maybe as we got closer we'd find more, but we didn't. We should have been suspicious of a few of the other features. This rather strange-looking ring feature here about in the center doesn't look like the sort of thing you find on the usual satellite.
That's not an impact? Or
No, it is not.
We don't know what it is.
We do now.
Oh, we do now,
didn't
all right.
know at the time.
We didn't know at the time.
First saw the photograph coming back from the spacecraft.
I see.
As we got a little closer to the satellite, we saw images like this. Now, this was evidence of lava flow. It looks like a collapsed caldera and a very thin spreading of the dark material, which was thought to be lava. It wasn't until several days after we had gone by Io that one of the lady engineers on our navigation team was working with some of the photographs, and she was trying to fit the circle of Io into a computer program, and it wouldn't fit because it had a funny-looking bump on one side of it. You can see if you look very closely down here, that strange-looking bump. Well, it turned out that was not an artifact of the imaging system. That was real. So we finally concluded, hey, we have a volcano, an active volcano, spouting out as we flew by. And not only was there one, but if you look at this other bright spot in the image here, you can see something is spouting up there. See, that's a portion of the satellite that's in the shade, or the dark side. Right. But the material is actually being ejected high enough so it's catching the sunlight. There's no atmosphere on Io, so any material coming out of a volcano tends to follow a ballistic trajectory, and it falls back to the surface. And the height of these plumes is something like 150 miles. A lot of material coming out. So suddenly we understood why the surface didn't have any craters.
Yes.
They're all covered up. Apparently this has been going on for billions of years.
Very active.
At the present time now, we have identified 7 active volcanoes which were erupting during the few days that we flew by it. You couldn't see anything like that if you flew by Earth. Volcanoes just don't go off that frequently here. I have several other photographs that demonstrate this a little more clearly. Here's a spout on the limb of the planet, and again you can see the big fountain of material. Now, we have pretty strong evidence that there's a great deal of sulfur coming out of these volcanoes, and that's covering the surface with sulfur, and a fair amount of it is also getting into the magnetosphere and leaving the satellite. There's another photograph of another volcano here. You can actually see the dark material coming and spouting out. And finally, a color version, a rather famous photograph showing an eruption right on the limb of the satellite. It's approximately in true color. Now, for scientific purposes, sometimes we enhance these photographs, and this is a composite photograph that includes some ultraviolet measurements, and you can see up here the eruption, and it enables us to determine the particle size coming out of the vent. So Io, I think, is nominated as the most remarkable object in the solar system. It's a very active volcanic object, and it's probably been going on for billions of years, and the surface is fresh, it's new, it's continually changing day by day.
Here at the Lewis Research Center in Cleveland, Ohio, we are directing work on modification of the Centaur rocket for use with the shuttle. Centaur will be used to launch the Galileo probe to Jupiter in 1986. Centaur will be carried into low Earth orbit. The rocket will be released from the shuttle, moved to a safe distance, and fired, sending Galileo to Jupiter. During the upcoming Galileo mission, we hope to learn quite a bit more about Jupiter and its atmosphere. Let's go to a film called Galileo Mission to Jupiter, which outlines the project.
The spacecraft carries a parachute-equipped probe targeted for deployment into Jupiter's turbulent atmosphere. The probe will allow our first direct sampling of the Jovian atmosphere and is a forerunner of future probes designed to explore the Sun, Saturn, and satellites like Titan with considerable atmospheres. The probe will descend into Jupiter to analyze and directly sample its atmosphere, believed to be original material from which the solar system formed 4.6 billion years ago. The Galileo mission, named for the Italian astronomer who discovered Jupiter's 4 large satellites, has been designed to use the gravity of those moons to bend the spacecraft flight path during its 24-month tour of the Jovian system. As the probe samples the Jovian atmosphere, scientific results will be relayed to the orbiter for 1 hour before the probe signal is lost at pressures of 10 to 20 Earth atmospheres. Galileo makes a close flyby of Io to study the moon's volcanic surface. Io's gravity in turn bends the trajectory of the spacecraft, helping to send it into orbit around Jupiter. Flying just 1,000 kilometers above the surface, images of the moon show features as small as 50 meters. After relaying probe science data to Earth, the spacecraft will orbit Jupiter at least 11 times, making a close flyby of one of the Galilean satellites on each orbit, yielding high-resolution images and detailed measurements of their surfaces, gravity, and magnetic fields. As the orbit rotates about Jupiter, the spacecraft will sample all regions of the planet's vast magnetic field. The first full orbit of Jupiter brings Galileo to its first encounter with Ganymede. The gravitational effect of the close equatorial flyby reduces the length of the spacecraft's orbit from 200 to 90 days. Using photographic data from Voyager, This computer-simulated flyby of Ganymede shows Galileo's view of the icy moon. Galileo will fly even closer to Ganymede in its second encounter with the moon. Each satellite flyby modifies Galileo's orbit, sending the spacecraft on to its next encounter. Each flyby is 20 to 100 times closer than the Voyager encounters. The Voyager saw only the equatorial regions of these icy moons, but Galileo will photograph the North Pole of Ganymede, providing a new perspective in the study of these large satellites. A flyby of Callisto occurs on the sixth orbit of Jupiter. The ancient, cratered terrain of Callisto is closely studied as Galileo passes over the southern hemisphere of the outermost Galilean satellite. The spacecraft will sweep within 200 kilometers of the surface of Europa at the end of its 8th revolution about Jupiter. Galileo's Europa encounters will give us our first detailed look at this moon's mysteriously fractured surface, seen by other spacecraft no better than we see Earth's moon through a small telescope. During its 20-month mission, Galileo will expand our knowledge of Jupiter and its satellites, revealing in detail the bodies and workings of this miniature solar system.
Through the years, we will learn more and more about the universe in which we live. Galileo is just the beginning of what is possible. This is Larry Ross saying goodbye from the NASA Lewis Research Center in Cleveland, Ohio, until next time, when we will travel to the next planet out from Jupiter, the great ringed planet Saturn.